Hey guys, welcome to the sequences and series topic. So this is our first video. It is going to be split into two though, because there's a lot of terminology that we have to go through, and then there's a lot of variations in the types of questions they can ask. So this first video, there's going to be two. The first one just telling you what all the things mean, and then the second one actually using the formula that we find at the end to find various things that they can ask us. Okay, so if we start on this first sequence here, and we've got our first value is 4, and then our next one is 7, 10, 13. Hopefully you can tell me that the pattern is just adding 3 each time. You can be asked to count the terms, and we use n for the number of terms, try and keep it simple. So n equals 1, n equals 2, n equals 3. Now this seems really basic, I know, but students get that confused with being asked to name the terms. So when we're naming the terms, we use a T for the term. Okay, so we're not talking about the number of terms, we're talking about the term itself. So we use T, and then we have this little subscript, you can see the little 1 there, that tells us that we want the first term. The second term is 7, third term 10, fourth term 13, and fifth term equals 16. So if the question said T4 equals, you would say T4 equals 13. Okay? So what we want to know when we're studying these patterns is what is T to the N? What is the nth term? Because they could ask us to find something like the 50th term or the 500th term, and you are not going to have time in an exam to sit down and work out 500 different terms. So you need to come up with a rule, a general rule, so that you can substitute in any n, any number of terms, and work out what that term is. Okay, so we were asked to do things like this before. That was back in year 7 when they gave you a table of values, and they said, well, what is the rule that relates y to x? So this was when we were doing things like finding the equation of a line. So if they gave us some points on the line and then they said, what's its equation? All right. So when you're finding this rule, you start looking for the pattern. So when x is 1, y is equal to 4. When x is 2, y is equal to 7. And you keep going. You say, well, y is increasing by 3 every time x increases by 1. So it's 3 times x, 3 times however many times x has changed. But if I do that, so if I do 3 times 5, I only get 15, but I actually need 16. So what's the rule? Well, it's 3x plus 1. Okay, works exactly the same way if instead of x's and y's you have n's, the number of terms, and tn, the term itself. So the rule for this, because it's exactly the same numbers, is tn equals 3n plus 1. Okay, and then you can use that to work out the 50th term or the 500th term. So if I substitute n equals 50 in there, 3 times 50 plus 1, 151, 3 times 500 plus 1, 1501. Okay, but there's a problem with that, in that that only tells us what a term is. It doesn't tell us what the sum of the term is. And when we're talking about sequences and series, it's quite often what those terms add up to that is the most important. One of the biggest applications of sequences and series is things like home loan replacements, putting money into super. I don't particularly care how much money you paid in February of 2025. What I'm going to care about is how much super you are going to have in total at the end. So unfortunately, the way that we did it before isn't going to be very helpful with the sorts of things we're going to look at. So we have to come up with a new way of analysing sequences and series. So now that you're year 12, this is the way we're going to do it. So we say the first term, as we looked at before, if I name that term, it's called T1. But what I'm also going to do is call it A. So the first term in my sequence is A. And it's A because that's the first letter of the alphabet, the first term in your sequence. Okay? So we call that A. And then we say, well, in this pattern, our terms are increasing by 3. Okay? So they're going up by 3 each time. And because it's going up by 3 every single time, we call that the common difference. So it is the common difference between the terms. And this is what makes it an arithmetic sequence. Okay, the fact that we're adding the same number each time. And if I want to add all of those terms up, then we call it an arithmetic series. So if we say, what is the sum of the terms? So if this was amount of money that a child was putting in their money box, and the first time they put in $4, and the second time they put in 7, and the next time they put in 10, etc., etc., how much is in the money box at the end? That's an arithmetic series, okay? And before we move into further examination, some things that we need to keep in mind. That common difference can be pretty much anything. So it can be a decimal, 3, 3.5, 4, 4.5, 5. Our common difference here is 0.5 or a half. Okay, it could be a negative number, so it doesn't have to be positive, it can be negative, it can be going down. It can be an account that you're withdrawing money from. It can be your home loan where you're paying money off and now you owe less. Okay, so the common difference here, well, it's decreasing by 2, so the common difference is -2. All right. It can also be a surd. So if we're going root 3, 2 root 3, 3 root 3, 4 root 3, what's the common difference? What's it changing by? We have 1 root 3, 2 root 3s, 3 root 3s. The common difference is root 3. So look at your definition now. So what is an arithmetic sequence? Well, if we name it T1, T2, T3, T4, etc., then an arithmetic sequence is a number pattern in which, pause the recording, see if you can figure out some kind of definition for it, and then start it up again and see how it compares. So an official definition, an arithmetic sequence is a number pattern in which the difference between every term and the one prior to it is constant. So what that means is if I was to do T2 minus T1, then I get the same answer if I do T3 minus T2, if I do T4 minus T3, and it goes on forever. It's the same answer if I do T100 minus T99. Okay? So that's the definition of an arithmetic sequence. And before I move on from here, there is a lot of formula in this topic. Without the formula, you don't have hope. Okay, so a good idea would be to have a little sheet, have a space in your booklet or a piece of paper where you're going to write down a little summary of all of the things that you need to know for this topic. Okay, here's a suggestion on how you could start that. All right, so the sequence T1, T2, T3, T4, you can see the n minus 1 and the n notation added there, and it's arithmetic if T2 minus T1 is equal to T3 minus T2, etc. That difference is equal to D. T1 is the first term, T2 is the second term, but we can also call T1 A. D is the common difference. D can be positive, negative, decimal, or surd, or pretty much anything else. N is the number of terms, and that has to be positive. We can't have -3 terms. Okay, so that's the start of your formula sheet. Write that down. Pause the recording, write that down somewhere, keep it and keep adding to it as we go through this topic. Alright, so we're going to look at this problem. The following number pattern is an arithmetic sequence. So they've told us it's arithmetic. So we know that they've started with 5, they've added a number and got x, they've added that number again, the same number, and gotten y, and then when they added that number a third time, they got 32. And we want to find the value of x and y. So that's a question I want you to think about. I am going to go through it in the second video, but I want you to think about, well, how could I work out what that is? Okay, so if I've started with 5, I've added the difference to get x, I've added the difference again to get y, and then I've added it a third time to get 32. What is it equal to? Okay, so where were we? Okay, so what we say is that the first term is a, and as we've just said, the common difference here is 3. Okay, so how can I use that first term a and the common difference d to find something like the 50th term or the 500th term or the nth term, so whatever number term they ask me to work out. So go back to your pattern again. T1 equals 4, so A is equal to 4, right? And T2 is 4 plus 3. That's how we got 7. And then to go from T2 to T3, we had the 4 plus 3 and then we added 3 again. and then we add 3 again, and then we add 3 again. Okay, so each time we find a new term, we're adding another 3. So the fifth term, this T5, which is 16, is equal to the first term, 4, and then 4 3s, 4 times the common difference. Figuring it out yet? How do I work out something like, say, T10? Well, we know it's going to be the first term because they're all started with that first term 4. Then how many differences did we need to work out that one? Well, go back again and have another look. All right, oops, too far. So for the second term, we added 1 difference. For the third term, we added 2. Fourth term, we added 3. Fifth term, we added 4. How many do I need to do for T10? What about 25? I want the 25th term. I'm going to do 4 plus how many times the common difference? All right, let's have a look at it just using our terms without the numbers. Okay, the first term is A. The second term is A plus D. First term plus the difference. Then there's 2 differences. Then there's 3 differences, 4 differences. T10, there's going to be 9 differences, isn't there? What about 50? Well, 50, there's going to be 49 differences. The number of differences is always 1 less than the term that we are looking at. So what about T to the n then? Well, T to the n is going to be A plus, please have a go at this before I reveal it, n minus 1 times D. Okay, so write that on your formula sheet. That's the end of the first video. The second video is going to go through some problems, okay?